If we have only two companies, A and B, where both are the only players in the market, if the total customers are 100 millions, and currently A is having 30% of the customers and B is having 70% of the customers. Assume if company A is losing 20% of their customers to company B, and also company B is losing 25% of their customers to company A. The transfer of customers is happening on a specific periodical basis. However, for the sake of this exercise, let's assume that the transfer is happening on daily basis. The question here, what will be the market share of each company after 90 days? The first solution to this problem is to look at the percentage of loss of each company, and we have the current market share, so we multiply each company percentage of loss by its market share. So 20% out of 30 million is 60 million, and 25% of 70 million is 17.5 million. So in first day, company A will lose 6 million and gain 17.5 million from company B. So 30 minus 6 plus 17.5 equal to 41.5 millions. The same for company B. 70 minus 17.5 plus 6 equal to 58.5. The new figures, 41.5 millions and 58.5 millions, represent the market share of each company by the end of the first day. The same exercise is repeated the second day. 20% out of 41.5 is 8.3, and 25% out of 58.5 is 14.625. So we do the math, and the net result in the end of the second day is for company A 47.825 millions, and for company B 52.175 millions. This exercise needs to be done 90 times to reach to the figure of 90 days, which is so tedious. The second method to solve this problem is by using matrices, using a specific technique called Markov chain. However, there is a particular situation called steady-state Markov chain or regular Markov chain, where the following equation is applied. S multiplied by B equal to S, which is the state or the current state, multiplied by probability equal to state, which is the new state. The construction of the matrix will start by the given information, which has to be in diagonal position, and can be in any of the two diagonal possibilities depending on where we put from and where we put to position. Then completing each column, in our case by 1 minus the probability, as the customers either to shift to other company or staying with the same company. We can extract two equations here, though we will need only one of them. The first equation is 0.75a plus 0.2b, and that's equal to a. Or we can have the second equation, which is 0.25a plus 0.8b, and that's equal to b. Let's use the first equation, so shifting a's in one side, so 0.2b will equal to a minus 0.75a, and that will be equal to 0.25a. So we divide by 0.2, so the net result will be that b equal to 1.25a. Now we plug in this equation, a plus b equal to 1. We use this equation, a plus b equal to 1, because the customers are either in A or in B. So by substituting the value of b by 1.25a, that would result in a equal to 0.4444 and b equal to 0.5555. Those values represent the share of other company as each is losing for the other company. That means that company A will have 55.555 millions and company B will have 44.4444 millions. These values are independent of starting company share. The idea behind this video is not the previous two solutions, but the third one. The third solution is that if we think about the given information, it's only 20 and 25%, which is 0.2 and 0.25, and the sum of both of them is 0.45. If we divide 0.2 by 0.45, which is the sum of both, we will have 0.4444. And if we divide 0.25 by 0.45, we will have 0.5555, which is the same as the previous result. The reason behind this equilibrium stage that we reach to, which has nothing to do with the initial status, is that there is a point where the number of customers exit from each company will be the same. So here, by multiplying 0.2 by 0.555 and 0.25 by 0.444, both will result in 0.1111. That means at equilibrium stage, the number of customers gained and lost are the same despite that they have different percentage of loss.